Let's begin with Docker. More specifically, I'm referring to Docker Engine, the software layer that acts as a manager for Docker containers. We're not going to concern ourselves here with Docker's inner workings, how it interfaces with processes and controls on its host system, and builds secure isolation between a container and its host, and between multiple containers sharing a single host. It's not that those details aren't important or interesting, but the thing is that we're more focused on helping you understand the practical stuff that'll help you design and deploy real-world applications on real-world infrastructure. If you're curious how all that stuff works, check out the links included with this lesson. As long as you're confident that Docker itself has been properly installed in your hosting environment, and that you're following all the security best practices, you're pretty safe leaving Docker and Linux, or Windows or Mac OS alone, to do what they do best. So then, what is Docker Engine? It's the orchestrator that gets all the key elements of a Docker environment to work together. Among those tools would be Docker-D, which is a class of system background process known as a daemon. It's Docker-D that actually controls the behavior of your containers. Requests are sent to the Docker-D daemon through the Docker Engine API, and primary access to the API is provided by the Docker command line interface. The CLI is controlled through the Docker command tool. This, by the way, is an active Docker environment running happily on one of my own local machines. By the way, I'm not going to show you how Docker is installed. For one thing, that's because the process will depend on your OS, and because the specific details can change from one month to the next. But there's another reason why I chose to skip over the installation stage, and that's because most serious Docker deployments these days are run on cloud hosts like AWS or Azure. For those cases, the engineers responsible for each platform are the ones on the hook for getting things right, not you. But getting the job done on Mac OS, Windows, or Linux is very well documented in plenty of official and reliable places online. Check out the text resources in this lesson for important links to various installation documentation resources. Just so you don't suspect I'm pulling your leg about having Docker installed here, let me launch a very simple container. Hello World is a tiny Linux image that's popular for verifying that Docker is running properly. All it does is output this introductory message. A Docker image is a template-based object that contains all the operating system and application resources you would need to launch a container. The Docker Hub image registry, which we'll explore in more detail a bit later, hosts thousands of pre-configured images built from just about any combination of OS distro and software stack you can imagine. As I'll demonstrate in a few minutes, you can easily download any one image and launch it as a container, or, alternatively, you can create your own images and upload them to either Docker Hub or your own private registry to make them available for collaboration. Launching an image as a container from the command line uses syntax like this. Run tells the system that you want to launch a new container. -D means you want to detach the current shell from the new container, so it'll continue running even if you close this shell. It'll also give you your command line back immediately. The --name argument gives the container a name. You can use any value you like. The -e argument sets the time zone environment value. I believe this is recommended to bypass a lingering bug in the Ubuntu install process. But don't tell anyone I said that. -p tells Docker to listen for external traffic on port 8080, and then send that traffic to the container on port 80. You can, of course, substitute any values that work for your system. And the final code points to the Docker Hub address of an image. In this case, I'm fetching the official Ubuntu image that comes with Apache 2 pre-installed. How did I get that specific image address? By searching the Docker Hub website. I usually prefer to work with official and supported images where possible, and Docker Hub will normally show me those at the very top of my searches. Back in my terminal, I'll execute that docker run command. Since the image doesn't happen to exist yet on my system, Docker will first download all its necessary elements, and then, after a few moments, launch a new container. Part of Docker's amazing efficiency is that it always tries to reuse existing resources rather than create or download extra copies. That 4D41 number is the container ID, should I need to reference it later. Docker PS shows me that my container is indeed running and healthy. And pretty much exactly the same way we did it in LXD, I can run docker exec to open a shell session in the running container. Of course, you will normally never do this. Remember, containers are more like cattle than pets, so you shouldn't ever need to log in. Let me show you that the Apache website is really live. I'll point my browser to the IP address of the machine that's acting as the Docker host and add 8080 as a listening port. And there's the Apache default welcome page waiting for us. Now, I'll exit the shell and run docker stop to shut the container down. One more execution of docker ps shows us that, once again, there's nothing running on my service. Next up, I'll show you how you can create your own custom image.